Okay, so this is going to be a quick objective. We have to talk about the idea that the geological processes that change the Earth take a very, very long time to take place. But different processes take a different amount of time. Now, most of the buildup to even the quickest process can take forever. All right? Seriously, a long time. But some of them are faster than others. So let's talk about that. These are the processes we've discussed in the previous videos that change the Earth: deposition, sedimentation, compaction, earthquakes, erosion, weathering, meteor strikes, plate tectonics, subsidence, uplift, and volcanoes. This is not an exhaustive list, but the main ones that I want you guys to know about. Now, for each of these processes, let's think about how long they take. So, first of all, which one of those processes will take less than a day to actually happen? Now, of course, it takes a while to build up to it, but the actual event is very quick. We're obviously talking about earthquakes. Earthquakes will be very, very brief. But technically, the actual meteor impact is very brief as well. It will happen in a split second, even if it took forever for gravity to pull it from where it is to where it actually hit, right? So these are very quick processes. Then you have events that take days, months, or years. They can last for a while. They will happen for a long time. Even if, again, the build up to it can take millions of years. What am I talking about? I'm talking about volcanoes. Volcanoes can erupt for a matter of days, for months. Some of them erupt for years on end. Of course, it takes millions of years to build up to an eruption sometimes, but the actual eruptions tend to be briefer than that. What about hundreds to thousands of years? We're talking about deposition, compaction, sedimentation, erosion, and weathering. These are processes that over thousands of years can break down rocks. Now, how long it takes, it could be millions of years. It depends on the size of the rock. If you're talking about eroding the entire Rocky Mountains to become something more like the Appalachians, that's millions of years. But if you're talking about eroding a rock, that's hundreds of thousands of years, or maybe even just thousands of years, right? It depends on how big the rock is and how much it rains and how much the actual process that happened will take place. Even the formation of sedimentary rock, that also takes millions of years, right? The pressing together of rocks to make it happen, hundreds to millions of years, hundreds of thousands to millions of years. But this is going to take less time than, say, millions of years for sure, with things like plate tectonics, subsidence, and uplift. Now, it is true that a glacier can melt over a period of thousands of years, and then uplift and subsidence can happen with the glacier forms or melts. So it can be a little quicker than millions of years, just like erosion can take millions of years. But when you're talking about the formation of entire mountains or entire valleys or huge deformations in the surface of the earth, like mountain ranges or entire plateaus forming, we are talking about millions of years through the process of plate tectonics. So these are not like set in stone. Ha! There's a joke there. But in general, you can say that basically earthquakes will be the quickest together with meteor strikes. And then you have volcanoes. And then you have processes which involve erosion and deposition. And finally, things like plate tectonics, subsidence, and uplift, which take millions and millions of years. All right? And so that gives you an idea of the different scales of time that these processes take. And that's objective 4. And I'll see you in the next video when I do a bit of a review of everything we did talk about in the entire lecture series.